Hey pilots, DrainMan here, and today I have a very special video. Today we are going to build the all-new Apex with KISS hardware, and we're going to build it from scratch. Let's go. Alright pilots, I am super excited. We are going to build the Apex frame by ImpulseRC, and we're going to use KISS hardware. This frame is a Mr. Steel tailored frame, but I'm not going to do it exactly like him. We're going to build it our way, but we are going to use his regulator board and his OSD. As you see here with the 4-in-1 ESC, you're supposed to use a connector. I do not have that connector. It did not come with the 4-in-1, and it did not come with any of the other equipment. So I'm going to use these solder pads right here that are broken out. I've got all my ESCs, telemetry, and power, and that's perfectly fine. I'm just going to go ahead and use these pads. It's not a problem. It's not going to mess anything up. It's going to make the wiring a little bit more difficult, but if you're building outside of the simple Mr. Steel kit with all of his connectors and harnesses, if you're building outside of that, this video might be very useful. It will show you how to wire everything up because I'm going to have to do it all manually. If you haven't built your Apex frame, that's not a problem. I'm going to go ahead and put a link to the Apex frame build because I have a video on how to build this frame. I'm going to link that in, and you can go ahead and use that. I bought here the Apex board, and as you can see with this regulator board, it does not come with any wires. It does have a very nice clean layout, and it also does have a bright big LED on it. I'm going to be happy to use that. Now, for my OSD, because KISS does not come with OSD, it's just like Flight 1 unless you're using the Flight 1 Revolt OSD, you don't have OSD. So it's pretty cool that if you're building the Apex, you can buy this Apex OSD. It's a very nice board. It does not have a driver on it, so you won't have to deal with any COM ports, any DFU mode. You won't have to use ZADDIG. It basically has auto configuration. It has some smart communication algorithm or something or another, and whenever you just connect KISS, Betaflight, or whatever it is, the Impulse OSD will all on its own. It'll switch to the mode that it needs to be in and get the data that it needs. Alright, so for our motors, I'm going to use the NIN motor. I'm pretty sure that I'm pronouncing that right, and it is a motor by Flywoo. It's called the Flywoo NIN. It is a 2306.5 1750 motor. It comes in a really cool like gunmetal color. I think it also comes in a gold color, but I do feel like that would look silly on this quad because I'm going to be running like a red, blue, and black kind of theme going on, a little bit of patriotic going. So I don't think we have any room for gold on here, but it does come in that color. And there's other models too, but I really like this one. I like the rounded bell shape. I definitely feel like this shape motor is going to be able to take a crash better than the traditional shape that most motors come in these days. Okay, so moving on to our PDB or regulator board. For the Apex frame, you can buy the Apex regulator, and it's made to fit right here in the back. It's got a 20x20 mounting style, so it fits perfectly, and the way that it's designed, it just works with this frame. So I'm not trying to reinvent the wheel. I'm just going to use it. But feel free to use the Wolf PDB, or you can use the Steel PDB, or you can just use any $5 or $8 PDB if you want. You do not have to use this PDB. So because this is the Apex regulator board and this is the Apex frame, as you see, it just goes together well. So once you've mounted it, now you're ready for the next step. So if you received your connector with your ESC, or you received one in the steel kit, then you're good to go. Me, I didn't receive anything. I don't know why. This ESC is almost $120. I don't know why I can't get a connector with it, but you know what? At the end of the day, I really don't care because it does fly really nice. So what I do is I go ahead and I tin all my pads, and then I found an old connector from an old KISS flight controller I had, and the flight controller was still good, but it had a connector in it that used to go to the steel PDB. So I cut it and I used that connector to solder it up. And what I had to do is I had to pull up the pin out for the KISS V2, and then I laid it next to me, and I went ahead and soldered these in the order that they belong. Now, when you get into beta flight and your motors aren't in the correct position, it's really not that big of a deal. You can go ahead and get into the CLI command, and you can do motor remapping. If you're not sure how to do that, I will link a video down in the video description. And that's one of the big differences between Betaflight and KISS, is that you have to have it in the correct place. There is no CLI command to just go in and flip things around. You do have a chance to remap your motors in the sense of, if you're rocking a 4-in-1 ESC, you will be able to flip its orientation. And that will remap your motors, but you won't be able to actually move a motor from one pad to the next. You'll have to do that manually with the wiring. Moving on to our Apex OSD, we need to get this thing wired up. Now that our 4-in-1 is connected to our flight controller, that's going to be our next step. Well, in order for the Apex OSD to talk to the flight controller, you have to solder it up on a UART. And if you have your wiring harness, you don't have to worry about that, but again, I didn't get one. So what I did is I used an old KISS plug, and I put my 2 wires where they go to the flight controller, and I took the other 2 wires and I put them according to the pinout of the Apex OSD, and they did lay out 2 solder pads, one for RX and one for TX, and I went ahead and used them. Keep in mind, if you don't do this, they will not be able to communicate, and you will not have OSD. The thing about it is there's a little LED on there, and it makes it pretty cool, and it's a red LED, and it flashes, and they actually call it the heartbeat, and it will move in a steady flashing, blinking motion. And it's pretty cool because you can tell if your heartbeat is steady, your signal is good. If the heartbeat is out of whack, then your OSD is probably out of whack. Now we've got our ESC and our OSD coming from the flight controller. Well, now we need to give our flight controller power. Generally that is done from the 4-in-1, but it's done through the harness. Seeing that we don't have that harness, we're going to have to manually give that power to the flight controller. So I went ahead and used the input voltage pads right here. I gave them a good 10, and I had preset a power and a ground wire when I was soldering up the wires on my 4-in-1, and now I'm going to go ahead and connect them to the flight controller. And that's going to go ahead and give the flight controller power. The KISS V2 flight controller can handle full LiPo voltage, so I went ahead and just jumped it right across. Now I'm going to stick on my bench supply, and I'm going to go ahead and just give it a quick little test, make sure everything's powering up, and make sure I have no shorts. And as you can see, not only do the blue LEDs look cool, everything is working just how it's supposed to. We don't have power in the OSD yet, but that's because we haven't gotten there. Next up is our regulator board, and this is specific to the Apex. Can you use it on another build? Probably. So what we need here is we need to give it power, because what this thing here is going to do is it's going to receive power, and then it's going to take that power, step it down, break it down, and distribute it out to where it needs to go at the correct voltages. Some of the things require 7.5 volts, some things require 5 volts, etc., so on and so forth. So what I'm going to do is give it full voltage and then step down out from there. Our first step in power distribution is going to be 7.5 volts, and that is going to head to our Apex OSD board. And that board requires 7.5 volts. I don't know exactly why, but that's what it's calling for. And then from there, it itself is going to distribute voltage out to its own components, whether it be the camera or the VTX or whatever you decide to use it for. So now you can see we've got a big hot mess coming along, and it's looking like a good hot mess, and it's probably going to fly good too, but it is a mess. So if you're not really understanding what's going on, that's why I've broken everything down into steps for you, and you should be able to follow along with me. Unfortunately, there is no broken out pad to give voltage to the OSD, so you do have to find a connector that works. For me, I make it a habit to save every connector, every wire, every component that I pull off of a frame or off of a board. I make sure that I save it just for reasons like this. And in my videos, when we build stuff together, I always tell you to save it too, just so you'll have the extras when you need it as well. So now that we've got our power brought to our OSD board, we've got power brought to our flight controller, we've got our power wires ready on our regulator. We just haven't given it yet. We're actually going to pull that from the actual LiPo connection. So for your LiPo connection, if you don't have an XT60 ready to go, you can go ahead and create one. I'm just tinning mine now. Then I'm going to go ahead and tin the pads on the 4-in-1. Once I've done that, I will solder them up, make sure I've got plenty of solder so there's a really nice flow. I don't like to be skimping on the solder when it comes to my XT60 because it's not just about flow of current, it's also about rigidity and strength. And if I've got extra solder, I've got extra strength. After I've done that, I'm going to go ahead and trim the wires for my apex regulator. Then I will strip the wires, tin the wires, and add the wires to these pads. And all that's going to do is take the current that is coming from the battery, it's going to go into the 4-in-1, but on its way it's going to shoot up the regulator and then power that entire cycle we have going that way. The Apex does have plenty of space for everything just because it's been designed a specific way. But I don't know if there is any space to get a capacitor in here. But this is going to be a 6S build. There's lots and lots of caps on the 4-in-1. But I still recommend putting a capacitor. I am personally going to roll without one. And then I'm going to see how it turns out. If it turns out great and everything's working good, then I'll just go ahead and call everything good. Now that all that's ready to go, our 4-in-1 is basically done. We are going to put on our motor wires, but we're going to do that after. The next thing we need to do is mount our flight controller. In order to do that, we've got to have standoffs. And when you're building the Apex frame, you kind of make that decision during that process. And if you've watched my video, then you probably already understand that. Or if you've already built your own Apex frame, then you probably would understand it as well. So what I've gone and done is I went ahead and I bought these HGLRC rubber standoffs, and you can find them online, and I'll put the link down in the video description, and you go ahead and you just twist them on top of the screws. So they're going to go ahead and do like 2 or 3 different things. One being holding down the 4-in-1. 2, going to be giving standoffs in a place for my flight controller to sit. It's keeping space between my 4-in-1 and my flight controller. And then to add the icing on the cake, it's going to self-mount it at the same time. Now we're ready for our VTX installation. As you see here, I have a Unify Pro V3, and there's a reason why. It's because I tried to use the TBS Unify Pro 32, and no, it just doesn't fit. Well, let's give the Unify Evo a shot. Well, guess what? That didn't work either. I tried double-sided sticky tape, I tried to mount it sideways, I tried mounting it in the back, and there actually was enough space in the back, but there was no way I was going to coil around the antenna wire and actually get it to work. So I had to go ahead and buy the Unify Pro V3. So I want you to keep that in mind if you're thinking about building this frame. You might not be able to fit just any old VTX. You might have to get a compact VTX. If you went with a Unify 32 Nano or something, you'd be in great shape, but you just wouldn't have the power output that something like this is going to have. To finalize our VTX, there's a little plate that you get for the back, and it's got a hole in it and then 2 other holes with threads. That's where you put the screws to hold your SMA adapter. If you're going to run MMCX or something like that, then this might not be useful for you. But if you're running SMA or got the V3, it's going to be perfect. I'm going to show you how to mount it later. So for now, just set that aside and get your OSD ready. So for the OSD, we're only going to put the camera and the VTX on there. There is some other pads and you can do some other stuff, but that's all I need to put. So I've got the harness from my camera and I've got the harness from my VTX, and I'm going to put them right here on the OSD. So I went ahead and grabbed the OSD pinout, which I've displayed here in the bottom left-hand corner. Using the pinout, I went ahead and gave 5 volts to the Unify V3 because that's what it calls for. I gave 7.5 to the camera, and then I put a common ground for both to help keep down on the video noise. So the next thing up is going to be our camera. It's a basic camera layout. You've got your 2 side plates that hold your camera, and then 2 kind of little screws behind that to adjust and set your camera angle. I kind of put mine in loosely at first, and then I set it after. After your plates are set, you go ahead and plug in the harness, and that's why we pulled out the harnesses, soldered them up, so that way when we add the component to the build, we just plug it in and we're done. I do love that about getting everything ready first. So now comes for one of my favoriteest parts about the Apex frame. But it's only good if you went ahead and bought the Apex OSD, and that's mounting it. I think it's absolutely awesome the way that they designed this and prepared this. The Apex OSD board fits right into the camera side plates without any effort, and it literally holds it snug and tight, ready for a crash. I really wish they would have designed something to work with this and the VTX, because I feel like there's absolutely no space for it. Alright, next up is our crossfire, because of course we've got to have a receiver. I am going to show you the quick installation, but I am not going to get into it too much. I have a full video on how to do everything with the Crossfire Nano receiver, how to wire it, how to connect it, how to bind it, and how to set it up. So I'm not going to do that in this video, but I will drop a link for you down in the video description. What you see here is something really cool. It's kind of like the OSD board. It's tailored to fit this frame, and it's just an accessory you get, and you can pick your color too. I think they've got red, coyote brown, and black, and it's super cool because it tailors to this Crossfire Immortal T. And once you've installed it, you don't have to worry about it getting chewed up by the props. But if you do happen to chew it up with the props, don't worry, because I've got a video on that too, and I'll link that down in the description for you as well. So as you can see with it mounted here, it looks really good. The next thing to do is to get the actual receiver connected to the antenna, and then we're going to put some heat shrink on it, and we're going to mount it, and then we wire it up. Man, this thing is really coming together. I can't wait to get in the air. I did want to mention that I throw a zip tie around the regulator board and the Crossfire, and it's not to overdo it, but we don't want it coming off during flight, but at the same time you don't want to have it too tight, because there is electrical components on that board, and if you over tighten them you could mess them up. Then I give my wires a nice little spin as usual. I had to unmount the flight controller so I can run the wires underneath nice and clean, because if I ran them on top it would just be too much, plus the wires would pass right over the gyro, and I really wasn't looking forward to that. Then I go ahead and tin up my pads. I cut them to length, and I got to solder up 5 volts for the Crossfire. You need your ground, and then you need your RX and your TX. I've gone over this plenty of times in a lot of my build videos, but if you haven't watched any, you've got to send your RX to your TX and your TX to your RX. It's not like you think. It's a little bit different than a traditional UART when you solder it up. And it's just because one is communicating through and out. So right here, I'm going to solder up my white smart audio wire on my VTX to this UART right here, so that way I can have Lewis scripts. I absolutely love Lewis scripts, and I won't go without them. I have a full step-by-step video for Lewis scripts. I'll be sure to link that down in the video description. I also have it for KISS and Betaflight, so depending on which one you're running, that will decide which video you'll watch. Now we're on to the motors. Now this is going to be the last part because we went ahead and got everything else done first. I normally put my motors on first, but this frame's a little bit different, so I went ahead and decided to do those last. You'll see here I've got the skid plates, and these are part of that package that we were talking about earlier, and it comes exactly fitted to the Apex arm, and I think they're really cool, and I think they're going to work great. I noticed that with the Apex arms are extra thick, which I'm not complaining because thick arms mean less brakes, but with the thicker arms means you've got to have thicker screws. So I did have a hard time finding screws. I did use a screw kit that I got on Amazon, and I'll link that down in the video description so that way you can use it if you need it. And then I went ahead and threw my screws in just to make sure they'd work. They were a little bit close to my motor windings, but they didn't touch, and this is very important. If you're new to FPV, do not let the screw come up from the bottom of your arm and touch the copper windings on your motor, because that's a recipe for disaster. Alright pilots, so with all 4 motors mounted, we are ready to solder them up. We need to solder all 3 motor wires from each motor to the 4-in-1 ESC. What's really cool about the Apex is it comes with these like little sleeve covers, and they actually came in an HQ prop bag, so I think they're manufactured by HQ, which is pretty cool because they make good props. So I like to see the companies working together like that. One thing that I was sure of when I put the sleeves on the arms is that the motor wires were completely flat. I laid all three next to each other and I made sure they were flat, because otherwise it's going to stand up and then it's not going to do its job properly. Some people might want to know, what exactly is the job of these sleeves? They are not just for looks. They actually serve a purpose, and it's an important purpose, because when you're running a 4-in-1, you have nothing on your arms but your bare naked motor wires. And if you bend a prop and you try to fly back, or you're still in flight, you're going to tear those motor wires up, and then you're in big trouble. And it actually happens quite frequently. So these protect it and keep it safe. Okay, so with all of our motors on, all of our motor wires soldered, it's time to put everything together. We're pretty much done. So I go ahead and mount the VTX now. This is going to be the final piece of the puzzle. Any Unify Pro comes with a double-sided sticky tape. I like that one because it's very thin and it's very sticky. It is a little bit bigger, so I trim it off, and I always have a hard time peeling off the cover that comes on the tape. I always use a razor blade. That always helps. When placing your VTX, you have to put it in this exact spot that you see me putting it in if you're going to use the mount that goes on the back. And I'm going to show you how to do that here in a sec. But if you don't place it there, you're going to have a hard time, because it needs to breathe and you don't want it touching nothing else, and there's really nowhere else to put it. So now, getting into the back plate, you're going to need two very long screws. They came with the frame. The screws are going to go all the way through the top plate, through this mounting plate, and then a couple of threads are going to stick out the bottom. Let me show you. Right there. And with that, you'll be able to grab the short standoff. So you would have noticed that the standoffs are a little bit short, and that's allowing you the space that you need to screw the screw in from the top. Don't forget to put your battery pad on. You need to choose between the rubber, or if you're going to put Velcro on your packs and rock the Velcro pad. You need to make that decision. All right, time to test the beast. Get your smoke stopper. Alexa, turn off the lights. This is the moment that every pilot prays doesn't go wrong. If you don't have a smoke stopper, guys, make sure you get one. It's very, very important. I really like these LEDs, and it's not like they're special LEDs. It's just the lights that come on the build. I mean, that one light's on the regulator, and the 4 blue are on the KISS flight controller. They're absolutely beautiful. I can't get over that part. I mean, normally you got to add LEDs to have your stack glow like this. All right, pilots, that's going to do it for the ImpulseRC Apex build. Everything is complete and working great. I do have a lot of steps ahead of me, along with programming the flight controller, flashing the ESC and the flight controller, PID tuning, rate setting up. I mean, there is a lot of work to do. But this video here has reached its limit. I wanted to show you guys how to build it, and that's what we did. I am going to have tutorials and videos on the rest of everything left to do for this build, and I've got that in the videos coming up ahead. I hope that you guys will be around to watch. I hope you enjoyed, and I'll see you on the next one.